So before we look at this example, let's just kind of, so let me just kind of do a quick review from last. So last class, so if you remember last class, we talked about combination of capacitors, so combinations. And we looked at two examples. So the first one is called a series combination. So let's say that we have so this is my, so those are two capacitors connected to so this is a body, this is my plus, and this is my minus. And then we'll say that this capacitor has a capacitance C1, and this has a capacitance C2. So it means that, then let's look at this other example here. So this is, this is plus, this is minus. So again, this is C1, this is C2. So what you see here is an example of a series connection. And what you see here is an example of a parallel connection. So we're going to say that this body is going to supply so this is delta V. This is also delta V. So delta V. So delta V is connection. Which in this case is just the same as the, it's called the voltage. Now, I think this is a key point here. So, in series, so for series connection, the charge that goes through Q1, the total charge in capacitor number 1 must be equal to the total charge in capacitor number 2, which we're just going to call Q. When you have two capacitors in series, the charge in capacitor number 1 is equal to the charge in capacitor number 2, but the voltage in capacitor number 1 is not the same as the voltage in capacitor number 2. Now in parallel, delta V1 is equal to delta V2. The Q1 is not the same as Q2. That's the main difference. And then we say that for a series, you can calculate, so for series, you use this equation to calculate the equivalent. It's equals to 1 over C1 plus 1 over C2. And then for parallel, you just do C equivalent. It's equal to C1. So I guess those are the basic equations that you need to remember to be able to solve any given problem. So keep this equation in mind. Let me go ahead and open a new window here. So second, we have the energy. So remember we said that if this is plus and this is minus, so take a body and just connect it to a capacitor. Then what is going to happen? This is going to become positive charge here. This will become negative charge here. So basically what you're doing is that when this is 100%, this is 100% charged, then if this is my delta V, so delta V here is called the charging voltage. Now when this is 100% charge, then the total charge that is stored here, so this will be plus Q, and this will be negative Q. So Q max is just equal to C times delta V. That's how you calculate the maximum charge, and then you can calculate the energy. The energy stored is given by Q squared 2C, which is also the same. You can also write this energy as 1/2 C times delta V.